Today's video, it's all about degassing aluminium with carbon dioxide gas. Now this is something I've never tried before. I'm going to use a soda stream bottle, and there is the lance just here, and that will be for going into the molten metal. Here is a close-up that shows it's carbon dioxide gas. Right, we've got our metal molten. This is the before mould, so I'm going to pour some metal before I've treated with carbon dioxide gas. Then after I've treated with carbon dioxide gas, we'll be pouring into this one here. I'm now going to machine the before gassing test casting. A sample cut has revealed some gas, as to be expected. And now comes the interesting part. I'm going to machine the casting that has been degassed with carbon dioxide. Here is the test cut on the degassed test casting, and you can see the gas there. And I think it looks worse than the original casting before it was degassed. So I've come to the conclusion it's a waste of time using carbon dioxide to degas aluminium. So why did I use carbon dioxide to degas aluminium? Well, about 2 years ago I used washing soda. Now that is supposed to be plunged into molten aluminium and breaks down and gives off carbon dioxide. Well, all I got was just a few bubbles and that was it. And yet everyone else on YouTube had a lot of bubbles. So I'll have another go at this experiment. And we'll see what happens. Here is the label on the packet, what the ingredient is. It's sodium carbonate. Now going to pour B mould, which is before degassing. This is the sodium carbonate wrapped in aluminum foil. We're going to degas it. Ooh, look at that. It's bubbling quite well. A lot better than last time. That's about it, I think. There's no more bubbles. Give it a quick scoop and clean out. This is the A mould. It's being poured after it's been degassed with sodium carbonate. This is the test casting I poured before I degassed with sodium carbonate. I'll do a slight test cut and see how much gas is in the metal. This is the test casting before degassing with sodium carbonate. There's still some gas in the casting, so I'll compare it with the one that's been degassed. This is the test casting that was degassed with sodium carbonate. I will do a test cut and we'll see what it looks like. This is the casting that was degassed with sodium carbonate. Oh yeah, there's a lot more gas in this one. Sodium carbonate has actually put more gas into the casting than removing it. So, why did the washing soda bubble so much this time round, and yet 2 years ago I only got a few measly bubbles? Well, this is the same stuff I used 2 years ago, but what I'm going to do, I'm going to show you an experiment where I'm going to make sure that there's going to be no bubbles. And what I'm going to do, I'm going to put some washing soda in there and then heat it up and drive off all the moisture. Now we'll put in some dehydrated washing soda. And now we'll put the plunger on. Just as I thought, Absolutely nothing. Whoop, no, we got one little tiny bubble come up, and that's it. Now I know what you are thinking. I have ruined the sodium carbonate washing soda by heating it up, and I've driven off all the carbon dioxide. Well, watch this. We use some vinegar. Oh, look at all those bubbles. Plenty of carbon dioxide there. Now, to prove that that is carbon dioxide, it will extinguish this match. And there you go, it's carbon dioxide. This is a book that I've got. It's called General Chemistry, A Systematic Approach. The publisher is the Macmillan Company in New York, and I'll show you some information about sodium carbonate. So here we are, we're in chapter 34. It's called the alkali metals. And the one that we're after is Na, and we'll find out what Na stands for. Right, we've got a location map of the United States of America and where alkali metals are mined. And Na is this one here. It's called sodium. That's what Na means. Here we are on page 650. It's a section about carbonates and bicarbonates. And this is the interesting part I'll show you. It says these alkali metal compounds differ from carbonates of other metals in two respects. Even when heated to very high temperatures, they do not decompose to give the metal oxide and carbon dioxide. So we move over to the next page. It says it is interesting to note that the only exception to this statement is lithium carbonate, which may be decomposed at atmospheric pressure by heating the substance to 1270 degrees C, which is way above the melting point of cast iron. Right, this book confirms what I've already found out, that sodium carbonate does not break down to carbon dioxide at the temperatures where you pour aluminium. But also sodium carbonate is a substance that will readily absorb moisture. So what happened 2 years ago, I opened the packet and left it open for 2 years. It did absorb a lot of moisture. And as I've shown, you can get rid of that moisture and it won't bubble. But it's a really bad idea to bubble moisture or steam through molten aluminium because it breaks down into hydrogen and oxygen. Hydrogen can increase the porosity in your metal. So what about the carbon dioxide gas I use to degass the aluminium? Well, carbon dioxide at aluminium pouring temperatures will break down into carbon monoxide and oxygen. Carbon monoxide is a very toxic gas, poisonous, but the oxygen will tend to burn the aluminium. But also with carbon dioxide gas supplied in those cylinders is a wet gas. It does have moisture in it, and that moisture will go through your molten aluminium and change into hydrogen and produce more gas in your castings.